Hi, and welcome to another episode of Mission Control. This is a follow-up video on the challenge I posted yesterday. A challenge that was aimed at Sleepy Wanker because he was very busy spewing nonsense in the comment section. As predicted by many of you, Sleepy has ignored all my pleas to submit a solution for the problem. However, that is not the case for the globe side. Two independent subscribers did the calculations and emailed them to me. The first one was from Where's Wally and the other one was from Arctic Haze. Thank you very much. Now, we don't arrive at the same solution for X, but that is just because we're not using the same density values, which is perfectly fine because these things are not static. The great thing about this challenge is that three of us have independently analyzed the problem and calculated the answer using exactly the same approach. And even though we use different values, the solutions are really not that far from each other. This is Where's Wally's submission, and here's Arctic Haze's. This is my own calculation, and here's basically how we all solve the problem. First, we gotta know how much helium is in the balloon. Since the balloon is a sphere, we can calculate the volume using this formula. Next, we gotta know how much buoyancy the helium exerts. Helium has weight, and gravity is actually pulling the helium down. It just happens that heavier gases are being pulled harder, which in turn forces the lighter gases upwards. We can calculate this buoyant force by multiplying the density difference of air and helium with the gravitational acceleration and the volume of the balloon. The result is 45.8 newtons in a negative direction. Then we move on to calculate the force of the ballast and the tank. I use 9.816 for gravity, as that is the force measured in Denmark. We then combine all the weights and see that the total downward force is 5,353 newtons. We then have to find out the equivalent amount of water. This is done here, and that amounts to 0.535 cubic meters, and this is the displacement volume that will take place in this scenario. Knowing the length and width of the tank, all we gotta do now is divide the numbers to get the height of displacement. And finally, subtract the tank height to solve for X. It's really not that hard, Mr. Riley, but if you want to stick to your relative density bullshit, I just want to say that you're better off getting your numbers from a fruit fly. You're very obsessed with saying stuff like math is not science, and basically you're the only person in the whole world who knows what science is, and that you outsmarted both Einstein and Newton. Yet you can't put your science to any use at all. That's just amazing, Riley. I believe this was another safe landing for the Globe team, so stick around for the next mission.